Good morning, everyone. Sorry for posting videos and taking them down. I've gotten some feedback on how I should be separating information that is directly related to the lab versus the supplemental help information to make the pre-lab stuff shorter, just stuff for the lab. And so we'll go into that. And I need to not tell you what will be on the quiz. You need to make it so that you have to look through the whole lab, study it, and be prepared. And I can do that. Now, even though I can't explicitly say what's on the quiz, I haven't even written the quiz yet, so I don't know what will be on it. And I don't think I ever was truly explicit because I try to put a lot of information out there. But I do want to say things generally that will be on quizzes or the possibility of being quizzed, and generally what won't be on quizzes. So the things that will be on quizzes will be like general safety. And again, everything that is quizzed has to come from the manual. So if there is a safety thing explicitly stated in a lab, learn it, know it. It could be on the quiz. So what safety precautions are explicitly stated? Gloves, doing things in hood. Last lab, there's actually a really good example. If you look at magnesium burning, it says, don't look at it because of UV rays that get emitted when it gets burned. Now, that wasn't on the quiz, but that would have been a fabulous quiz question. Something making sure that you knew that fact that was safety related. And keep that in mind when you're reading the quizzes. Mark all the safety stuff, highlight it, make sure you know every safety concern that is explicitly stated. Proper waste disposal is another similar thing, especially when there are more stringent guidelines. Last time they're just like put everything down the drain. That really wasn't worth quizzing you on. But any case where there's stringent guidelines like make sure you do this for waste, well, then that's a good thing to make sure you guys know before coming in. So that would be a good thing. And also to make sure that you guys are, so that's the safety stuff. The other thing that I want to do is make sure that you're prepared for the quiz, for the lab. And so, yes, being prepared for the lab means knowing procedure stuff, but not knowing what volume is needed for weighing out this stuff. No, like you're going to have your notes. I'm not going to ask you about volumes. I'm not going to ask you how much does it tell you to weigh out or anything like that, because you can just read it. Like that's the whole reason of following the procedures. You don't have to memorize procedural stuff. So don't worry about memorizing what molar of this are we using or something like that. But I want to make sure that you're prepared in the sense that the goal is so that you can understand what is happening and confidently answer the questions at the end of the lab. So if you want to know what things I'm going to gear questions towards, look at the end of the lab questions, because hopefully by the end of the lab, you can do that. And there's things in the lab that teach you how to do that. Like the end goal is to turn in your lab questions and get as many points as possible. And the lab manual gives you, it teaches you things to help you turn in that and get all your points. The quiz is going to help make sure you've learned those things so you can answer those questions and get all the points you can. And that's a good way to think about what types of things I want you to know for a quiz. I want you to be prepared for safety reasons. I want you to be prepared to answer those questions at the end of the lab. So pay attention to that. Now, the other thing that I was told is like, you give them so much information, you're going to overwhelm them. And some of you guys too are like, oh, they're so long and jump around a lot. I will try to fix that. I will try to make my pre-lab videos more concise and just the stuff directly related to the counsel that I've been given to share with you, and the things in the procedure that need to be pointed out. That being said, I love teaching. I love seeing you guys succeed. And you guys are like sponges. You want knowledge and truth. You want to feel prepared. You don't want to feel confused. And you're just hungry for info, especially if you don't understand something. And I understand that. And so in some of the past things that I've done, I've been a tutor. I've been an SI leader, supplemental instructor. I wish they had more of those here. And essentially it was like a dedicated time for weekly review for students. And TAs were hired to fill those hour review sessions. And they weren't office hours. Office hours, you guys come with questions. Supplemental instruction, the teaching assistants would prepare material based on the lectures or other things and say, these are the things the professor covered. Let's review them with more examples. And the thing that was so obvious is when it came for tests and quizzes time, the people who went to SI had better grades. That's just fact. Now, SI was optional. You didn't have to go. And same thing for the stuff that I'm going to do. So I'm going to try to do a better job of separating the pre-lab stuff and the supplemental help stuff. And I still think that that's important. They might be long videos. They might jump around. But the purpose is there's a wide range of chemistry experience in our labs, from zero to probably got some AP Chem people in here or other things. I don't know. And for that reason, I still think it's important for people to have a way to not feel like, oh, I'm so far behind, I have no way of succeeding. I know everyone can succeed. Everyone can succeed in this. Just need to be able to know where to find the information. And so I will still make videos on, they'll just be supplemental instruction. You don't have to watch them. There's not going to be anything that's quizzed on in those videos. There's not going to be anything that is safety. I'll cover the stuff that will be quizzed on in the lecture video, and I'll cover the stuff that's safety related in the lecture video. But we'll do examples. We'll talk about real world situations. We'll look at information you can find in SDS sheets because they're super useful for keeping you safe and just learning about the chemistry and how reactive things are and all sorts of other things. Talk about fun examples, tell you examples from my own life. I'll also talk about like how to think. Like we'll go over the procedure in the first one, but like, why are we doing it this way? And things like that. Now, to make sure that it's not necessarily like an unfair advantage, like you guys get so much supplemental information, these videos will be public. Before they've been unlisted, and so you had to have the link in order to get there. But, you know, if you have people in other sections or maybe the other TAs want to use these things, these will be public videos so that anyone who wants to know more about the lab can go back and look at them. And in addition to that, some people said, I can't find time to ask you questions in those videos. That's also what tutoring office hours are for. The nice thing is labs, my sections are on Tuesdays and Thursdays. I also have office hours in the morning on Tuesdays and Thursdays. So from 8:50 to 9:50 a.m. Tuesday and Thursdays, I am in the chemical resource room, chemistry resource room, available to answer any questions. So if you prepare for lab the day before, go through everything, still have questions, want to come to office hours, please do so. Also, people have texted me questions, emailed me questions, and I see those and I respond. Some of the questions are really good, and I realize I need to send out an announcement and actually be like, a lot of people might have that question. So that is why the videos are a little bit later. I've tried to make a couple changes. I took down the old ones so that I could implement these changes this week. Now we are going to jump into periodic properties, group 7 stuff. So we have the introduction. The introduction has some really key points in it. It talks about how elements in the same column have similar but not identical characteristics. And that's what we saw with group 1 and group 2. We're going to be looking at that trend again with group 7. And then also says how halogens towards the top of the periodic table are usually gases. And that's just an important fact to know. As you go up, they're usually gases. And the objective, we got 4 objectives that we're going for: oxidizing strength, solubility, bond strengths when reacting with silver, and the physical characteristics. So we've got that, and then experimental procedure. We'll do each of those sections: physical properties, oxidizing strengths, solubility, and bond strengths. For some of the just quick safety things for this, we have bromine and chlorine gases that are being used. And procedurally, it talks about you need to weigh out 2 mils of chlorobenzene with bromine in it, and the TA gets to do the chlorine. We actually have a slight change. There's some replacements that have been done. So instead of chlorobenzene with these dissolved gases in them, we're going to be using water with these dissolved gases in them. And it's safer to be doing it that way. And yeah, so that's just a small change. Hasn't made it into this manual yet. Hopefully it will. And they're easier for the store to purchase and deal with also. So because it's in water, when it says measure out 2 mils of chlorobenzene with bromine in it and 2 mils of water and put them together, you don't have to do that. It's already in water. So you just need the 2 mils. So in your manual, wherever you're looking at it, do that. I actually jumped ahead. We got to go to physical properties first. There'll be some stuff in the ADA hood back here, and those examples need to stay in there. And you can look at them. You're going to want to record the color and the physical state of it. That'll be over there. And continuing on, you can see that those things are in the questions up here. A good thing to do, actually, when you're about to read the lab, is a super good recommendation. You should do this. Don't read the lab front to back. First, go to the questions. See what you're going to be quizzed on, not quizzed on, sorry, what you're going to be asked to answer in lab. Those are the questions. Look them all over. Read every single question. Like, okay, these are the things that I need to figure out. Now go to the first page and start reading. And that'll be just useful at helping you have more purposeful reading when doing this. And you can see section 1, physical properties. Also, highly recommend maybe start ripping out this page. That way you can have it open to the procedure while you're going through it. You'd have the procedure in the notebook and the thing that you're recording everything on right next to it. So we've talked about physical properties, and that's section 1. Section 2 is the oxidizing strength of halogens. And this is very similar to what we did in the previous lab, where we're comparing things up and down a column to see who reacts strongest or weakest with each other. There is a chemical equation here, and I'll have some supplemental information in the other video about writing chemical equations and how to understand what's happening in chemical equations. If you're not comfortable with that, you can look for that. Continuing on down, it talks about what things you should look for. It also says wear gloves for all parts. That's important for this. And talks about looking for color changes for these oxidizing things. When it comes to measuring things out, it says 2 mils. You should do 2 mils. I do want to say, though, the thing that annoys me, so when I've said, like, oh, it's qualitative, not quantitative, the thing that annoys me is when I see someone weighing out something for a qualitative thing incredibly precisely. So if you have a graduated cylinder, the way to perfectly measure with the most significant figures is to get down at eye level at that mark and make sure that the bottom of that meniscus is right at that mark. And so in this case, that'd be for 2 mils. But That's if you want to do quantitative stuff. Now, what would 10% air be of 2 mils? That's 0.2. What about 5% air? These are very small airs. 5% air, that's totally allowable for a measurement that is qualitative. So that's 0.1 mils. So when I'm saying it doesn't have to be precise, like, yes, you need to measure out 2 mils, but what's 5% air? Maybe you're not getting down at eye level. And so you're just looking at the 2 mils. So measure out 2 mils, but don't worry about, oh, I put an extra drop in and that meniscus is now slightly above that 2 mil mark. It's not going to matter that, but measure out what the lab manual says. Just realize it's qualitative, not quantitative. Quantitative is organic chem, when you get points taken off if you don't create the right amount of product. Maybe we'll have labs like that, but so far we haven't had too many. We have more chemical equations on the next page. Again, supplemental information will be coming on how to feel comfortable with what's happening there. Make sure you can do that. And then it talks about the parts that you guys will be doing, which is the bromine. Again, we don't have bromine dissolved in chlorobenzene. We just have straight bromine water. And because of that, you don't have to mix 2 mils this, 2 mils and that. You just need the straight 2 mils of bromine water. And you can use that. Also need to make sure that you've got stuff corked. We don't want these things spilling, causing gases and things like that. Bromine and chlorine, they do cause gases to be released, and they'll burn your nose and sinuses and things like that. So make sure you've got corks for your test tubes when you're taking these things. Continuing on down, it talks about some of the science that we'll be observing. Lots of stars, very important principle to realize. This is going to help you understand whether or not it has greater oxidizing strength than something else. If the above reaction occurs, then the reverse reaction will not occur. That's really important to realize. And just keep that in mind. We're on to solubility of stuff. For this, we've been told to take small amounts of these salts. By small amounts, it says the tip of a scapula, but a better visual example, we've got matches here. You're supposed to take only the amount the size of a match head. So that amount right there is how much of these different things you need to take and try to dissolve. Then fill the tubes with water, about 1/3. And boiling water baths. We've looked at these before, double boilers, things like that, boiling water baths. So you're going to have a beaker of water, and that's going to be boiling. And then, or an Erlenmeyer flask, I don't know exactly if it specifies. And you're going to put your test tube in that water so that there's even temperature distribution on the bottom of that test tube. Because if you think about it, the surface area on the bottom of a test tube is very, very small. If you tried to put it on a hot plate, it just wouldn't work. Plus, the water means that it will not get above 100 degrees Celsius so long as it's boiling. If fill tubes about 1/3, it does not say if you should use a beaker or an Erlenmeyer. So use an Erlenmeyer because it has a narrow neck, and you can use those test tube tongs to hold the test tube across the opening and just set it there, and it'll just hold the test tube there. You don't have to keep your hand so close to the hot steam. Relative strengths of halides. So again, more chemical equations. There will be supplemental information on how to write chemical equations because it's really important for answering the questions later on. And if you don't have a lot of experience with that, I want you to find a way to get more experience. So it talks about the chemistry that is happening, and it gives some terms here that I actually hadn't heard until I was a master's student. So decant that means to pour something in such a way that you keep the solid chunky stuff in the bottom of it, essentially, without letting that out. What do we have here? So magnesium chloride, it's safe. I don't care that I'm touching it without gloves. Say this had a liquid in it, but there was some solidy stuff down here. Decanting just means like you're just pouring it off slowly, trying to keep all the solid stuff at the bottom, but let the liquid off. And if there's like a little bit of liquid, it shouldn't matter too much. Yeah, so you're just trying to keep as much of the solid in there and get as much of the liquid into the corresponding waste beaker that you have. So there's that. The other words, precipitate, we've already looked at that last time. That's anytime that something is sort of coming out of the solution that was originally dissolved into the solution. We saw like a cloudy film that would settle on the bottom of beakers last time. I don't know exactly what this one will be looking like, but if there's precipitate, that's what you're looking for there. Supernate, this was something that I had no idea what it was. Whenever you centrifuge something, so you take something and you spin it around, it forms a pellet of the solid chunky stuff at the bottom, and then there's a very clear liquid layer on top. The supernate is that top liquid layer, and then the pellet is the bottom chunky layer. So it's very much telling you to decant again. They should use the same word, decant. So you're just pouring off the liquid. It says pour off the supernate, pour off the liquid. Ammonium hydroxide, it really burns your nostrils very bad. So don't sniff it. And yep, I'll tell you a story about that in the supplemental info. And finally, this is something to really think about before coming into lab. You're going to be given an unknown halogen, chlorine, bromine, iodine, is what it says. And you need to figure out what halide it is. So if you've gone through all this procedure stuff, you can see that we're testing different properties and we should get different results. You should then be able to take your unknown and perform these same procedures and observe similar comparable things to figure out what halogen it is. And if you look at question 5, this is why it's important to read the questions beforehand and know what you're aiming up for these questions. Describe your plan for determining the unknown halide. So hopefully by going through this and knowing that that's what you're going for, you can keep that in mind. Like if I had an unknown halide, how would I be testing for that? Finally, for the questions, don't leave anything blank. Be sure to answer everything the question's asking for. If you look, there's all these sections where it says write out the chemical reaction and make observations before mixing, make observations after mixing. So if you have problems writing balanced reactions, I'll find some supplemental information to help you with that. There's a possible typo in section 3, but I'm waiting to hear back if it is a typo. And yep, write balanced reactions. Lots of balancing of reactions. So make sure that you can write balanced reactions. That being said, don't pre-write these balanced reactions in your lab manual. We're looking out for cheating, and that's one thing to look for, is make sure people don't have answers pre-written in. So do not pre-write in things into your lab manual, but make sure that you're comfortable and prepared to do these things in lab. That is